Hello again, Year 9, and welcome to what is our 5th angles lesson. And today we are going to be exploring angles in a quadrilateral. Well, what is a quadrilateral? Quad. Quad means four. So we're going to be looking at the angles in a four-sided shape. Do you know all the names of your four-sided shapes? Do you know what they all look like? Let's find out. So, as a similar activity to yesterday, all I would quickly like you to do is just look at these shape names, have a look at the diagrams, and see if you can match the correct shape to the correct name. Pause the video here and have a quick think for 1 minute. So I'm going to go through the shape names in alphabetical order. So the arrowhead, I'm sure you got right because it looks exactly like it sounds. It is shape number 7. The kite, again, looks like what it sounds like. It is number 6. Parallelogram. Now, parallelogram and rhombus are the two shapes that students normally mix up. Parallelogram is the wonky rectangle, and the wonky rectangle is number 3, with the rectangle being number 2. The rhombus is number 4. Please never refer to a rhombus as a diamond because that will be marked incorrectly. The square is number 1. And I've done a very special type of trapezium here. This is called an isosceles trapezium because 2 of the sides are the same length. But that one was number 5. Did you get them all right? So today we are looking at angles in a quadrilateral. And we have a rule for the four-sided shape that the angles must add up to 360. So yet another rule and another number that you will need to remember. But have you ever wondered why do the angles in a quadrilateral add up to 360? Because we can explain this fairly easily. If I take my shape ABCD and look at it slightly differently, what I'm going to do is I'm going to split it across that diagonal there. And I have these angles in my top triangle and these angles in my bottom triangle. But if you just compare my two diagrams, this is still angle B. These two angles would be angle A. These two angles would be angle C. And this would be angle D. Well, we know from angles in a triangle that the angles in a triangle add up to 180 degrees. So this triangle has to still be 180, and the triangle beneath it still has to be 180 degrees. So altogether, that is 360 degrees. So that is why the angles in a quadrilateral, whatever shape it may be, always add up to 360 degrees. Let's look at some questions and examples of the type of thing we might be asked to do today. So it says calculate the missing angles, show your working out. So we have a quadrilateral here. We know the angles in a quadrilateral add up to 360 degrees. So a lot like how we did the triangles, I'm going to see what angles I've already got and what they add up to. I'm sure we all remember what this little square symbol means. Remember, that is a right angle, so that is 90 degrees. So I'm going to use some place value to add these up. As I get into more complicated shapes, I rely a little bit less on doing things in my head and a little bit more on traditional written methods. So 7 add 1 is 8 for the units. 8 and 2 is 10. Add 9 is 19. And the 1 that I carried to the hundreds is 2. So those angles add up to 298. If I want to work out angle A, I can subtract that from 360. And that is 62 degrees. In my second diagram, I still have a quadrilateral, but I have a little extra baseline. So perhaps you can anticipate what extra angle rule we might be using here. If I am going to work out this shaded angle, I'm going to have to do something first. I'm going to have to work out this angle here. And this doesn't have a letter. Let me call it B. Let me call this A. So I'm going to work out angle A first, just looking at the quadrilateral. So let's add up the angles that I do have. So I've got 55, 125 and 86. If I add those together, the units adds up to 16. Adding the tens, I can see 8 and 2 is 10, so 15, 16. And an extra 1 makes that 266. So I can work out what I've called angle A by doing 360, take away 266. 360, take away 266, and again use a place value method if you want to, is 94 degrees. Let me just quickly check that. So if you do want to use a place value method, we've got 0 take away 6, you can't do. So we need to exchange a 10 for 10 units. 10 take away 6 we now can do. That's 4. I go to my tens column. 5 take away 6 I can't do. So again I have to exchange 100 for 10 tens. I now have 15 tens. 15 take away 6 is 9. And 2 take away 2 is 0. So yes, 94. But that is angle A. I was trying to work out this shaded angle, which I've called B. So what's the extra angle rule that I'm going to use? Yes, it's angles on a straight line. So B is 180, take away 94, and 180, take away 94. Again, place value method. 0 take away 4, I cannot do, so I will exchange. 10 take away 4 is 6. 7 take away 9 I can't do. So again I will exchange. 17 take away 9 is 8. So the answer to that one is 86. And again, always try and avoid with angle questions to use your calculator, because it's great practice of either mental maths or those written methods that we did some work on earlier last term. So once again, there's some questions for you to try. Please draw them out using a pencil and a ruler. You do not need to draw them out the exact size. You are not measuring these angles out with your protractor. It's a diagram that just roughly looks the same. Don't make it too big, don't make it too small. Show your working out, and remember, all of these questions are on the PowerPoint link, so do read the instructions again, and all those answers can be checked at the end of the lesson. Remember, any problems, any questions, there is the Ask the Teacher channel in your team area.